Okay, integration by substitution. We've sort of looked at this a little bit and I've shown you. I'll do a couple of examples and I'll come back to the steps and the reasoning. If I make u equal to x squared plus 1 and differentiate it, 2x, then du is equal to 2x dx. So I want to integrate with u because it's going to be easier, but I can't integrate u unless it is du. So I need to sum in what I know. I know this is u, so it's u cubed. 2x dx is du. I can integrate that pretty easily. That's u to the 4 on 4, which is x squared plus 1 to the 4 on 4 plus c. So I found u, I found du dx, differentiated it, made du the subject and substituted it in. If I've got boundaries, these are x boundaries. So I either need to find u boundaries to substitute in or change it back to x. I find it easier if I find u values. It's given you a hint here, so I'll make u equal to x plus 3 to the half. Du dx is half x plus 3 to the minus half. So du equals 1 on 2 root x plus 3 dx. Isn't that 1 on 2 u? Because isn't this u? Didn't we say that was u to start with? Dx. So let's sub in what I know. I know that I've got x u I think I'm in a bit of a pickle. U hold on, I've made a bit of a mess. This was not a good one to carry on with. Du, I want to replace dx. So from over here, I've got du times 2u equals dx. It's easier if I sub in the dx. So I've got du times 2u. But what is x? X is u squared minus 3 is x. So I actually have this happening. It's a bit messy for a second example. Sorry about that. I've got this happening. X, which is u squared minus 3, times 2u squared du. So I've got 4u to the 4 minus 6u squared du. Now, if x is 6, u is 3, by subbing it into here. And if x is 1, u is 2. So I want to integrate between 3 and 2. So I just carry on as normal. 4u to the 5 on 5 minus 6u cubed on 3 between 3 and 2. And I'm going to come over here, which is 4 times 3 to the 5 on 5 minus 6 times 3 cubed on 3 minus 4 on 5 times 1, which is 4 on 5, minus 6 on 3. And we'll get an answer.